Hello everyone. Today we're going to learn lesson 1.6, classifying polygons. So you're going to learn how to classify a polygon by its sides and vertices. We're going to talk about some vocabulary such as convex and concave and regular, equilateral, equiangular to distinguish polygons. So first of all, the term polygon. Let me get out my notes. So the term polygon means many angle. So poly means many, gon means angle. For a figure to be classified as a polygon, it must be a closed figure. That means that there can't be any open gaps in the figure. So for example, that would not be a polygon because there's an open gap here. All of the vertices have to connect. Formed by segments in a plane. So segments meaning that there can't be any curves. So no curved sides. It'll have to be segments. In a plane, segments are straight. In a plane, so that the sides of the common endpoint are not collinear. So, for example, you can't have a side, a vertex, and then the other side, and this be a straight angle 180 degrees. So you can't have that. And then each side intersects exactly, well, and back to this, you have to have some kind of angle here other than 180. And then each side intersects exactly two other sides at their endpoints only. For example, if we took this and we did extend it to close it, but it met at the side of this segment rather than its endpoint, then that wouldn't be a polygon. So let's look at some examples. So it says, which of the shapes would be considered polygons? So pause for a minute and decide which ones would be considered polygons. All right, so number 1 would be considered polygon, number 2, number 3, and number 4, because they're all closed figures and they meet the other requirements. These 3, however, would not be considered polygons because they're not closed. And number 7, there's an overlapping segment here. So 1 through 4, and then the ones that are not are 5 through 7. So this note down here, each endpoint of a side is called a vertex. To name a polygon, you list the vertices in consecutive order. So, for example, let's say we have a quadrilateral. A, B, with vertices labeled A, B, C, and D. So there are a couple different names to name this. The most common way is to start with the smallest letter of the alphabet, which would be A, and then to go around. So it says a consecutive order, that means just all the way around in order. So the most common way to do it would be to write it in alphabetical order if possible. So we could say A, B, C, D. However, you don't have to write it in alphabetical order. We could go, instead of clockwise, we could go counterclockwise. So you could say A, D, C, B, as long as you're naming the vertices in consecutive order. Also, you don't have to start at A. You can start at B. So you could say B and then go clockwise, C, D, A, or you could go the opposite way, counterclockwise, B, A, D, C. Okay, as long as you're doing it in consecutive order, you can start anywhere at any vertex. Go counterclockwise or clockwise. So let's talk about the difference between convex and concave. So convex, if you extend any segment of the polygon to make a line, so what does that mean? Well, let's take a look at the number 1 polygon. So if you extend any segment of the polygon to make a line. Okay, so let's take this one and extend this segment to make a line. And let's just go ahead and do all of them. Okay, now notice that none of these lines are going through the polygon. They're all going outside of the polygon. If you take all of them and do that. So a convex polygon, if you extend any segment of the polygon to make a line, no point on that line, so in other words, that line is on, no point on the line is on the interior of the polygon. So the line will not cross through the polygon. So it won't cut through. So which one of these would be considered convex? Well, number one, this would be convex. And actually, let's talk about concave before we do the next one. So concave is the opposite. The polygon is not convex. So in other words, the segments do, if you extend the segments, they cut through the polygon. Here's the way I like to think about it. Concave has the word cave in it, and it's like if you extend the segments and it goes through the cave, like inside of the cave representing the polygon, then it's concave. That's a little trick I like to think about it. So let's decide which ones would be convex or concave. So let's take a look at number two. So let's extend each segment. So let's extend these segments. Well, that's safe. That one doesn't cut through the polygon. But what if we take this segment here? Cuts through. So that would be considered concave, sorry. So as long as one of the segments, at least one of the segments cuts through, then that makes it concave. How about here? So what if we extend this segment? Well, we're good. How about these ones? Those ones are good. But what if we take these segments here? Well, that one cuts through. And this one cuts through. So this would be concave. How about number four, a triangle? Extending the segments. None of the lines will cut through the polygon. Unless I make my lines really bad. And they accidentally do. Okay, and then these ones, okay, so this would be convex. And if it's not a polygon, it can't be convex or concave. So it says a convex polygon is a regular polygon if all the sides are the same length and all of the angles are congruent. So they have to have the same length and congruent angles. Do any of the polygons above appear to be regular? So which of these look like they have the same angle measures and the same side lengths? Number one. Number one is an octagon, a regular octagon. But of course, we couldn't tell exactly unless we knew for sure that all of the sides and angles were congruent, if we were given the angle measures and side lengths. You can't always trust the diagram. All right, let's talk about classifying them by their sides, classifying polygons by their sides. So how about if it has one side? What kind of polygon would it be if it had one side? Trick question, not a polygon. You can't make a polygon with only one side or two sides. So I'm going to put just quotes here. That means what I said above, not a polygon, instead of rewriting it. Number three sides would be a triangle. Four sides, quadrilateral. Five sides is a pentagon. We'll see an example of a pentagon in this lesson. 6 sides is a hexagon. 7 sides is a heptagon. 8 is an octagon. That's like your stop sign. 9 is a nonagon. Nonagon. 10 is a decagon. Deca means 10. How about 12? A dodecagon. Oops. I must have skipped something. What did I skip here? Oh, no, this just got pulled down. All right, there we go. So a 12 is a dodecagon. Okay, anything else would just be considered an n-gon. So whatever n is, like if it's 30, then it's a 30-gon. All right, so another, just touching base again on equilateral, equiangular, and regular polygon. So equilateral means all the sides are congruent. All sides are congruent. An example of this would be a rhombus. So a rhombus has congruent sides, but only the opposite angles are congruent. We'll do a lot more about quadrilaterals in chapter 8. So even if it's equilateral, does not necessarily mean it's equiangular. Equiangular is just what it sounds like, that all angles are congruent. So if you had a quadrilateral and it was equiangular, there are 360 degrees in a quadrilateral. What would the degree of each angle have to be? Well, they have to be equal, so you have to divide it into 4 equal shares, which would be 90. So they all have to be right angles. But just because they all have right angles doesn't mean that it would be square. So what if we had opposite sides congruent, but not all sides congruent? So if we have 1 tick here and 2 ticks here. Oh, by the way, so if all of the sides have the same number of ticks, that means that they are congruent. If they have different number of ticks, that means they are not congruent. So these two are congruent, and these two are congruent because they have 2 ticks. Same with angles. So if you want to differentiate the congruent angles, you could use 1 arc for these ones being congruent, and then 2 arcs for these ones being congruent. You can see examples where there are like 3 arcs or 4 arcs or 5 arcs, probably at the most, but that's how you distinguish different angles, is by giving them different arcs or different numbers of arcs. And then a regular polygon would be both of these combined, so all congruent sides and angles. Back up here, the example for this would obviously be a rectangle. And then if you combine a rhombus and a rectangle, you get a square. So all congruent angles, so 90 in this case, all congruent sides. A square. All right, quick example here. So a pentagon. The figure at the right shows an outline of the Pentagon building near Washington, D.C. The building is a regular pentagon. Regular means all of the sides are congruent, all of the angles are congruent. Use the diagram to find the following. Find the length of one side of the polygon. Okay, well, if the sides are congruent, you can mark them congruent. That means we can make an equation, set 20x equal to 12x plus 112. I'm going to just do that over here. 20x equals 12x plus 112. Okay, solve for x. So this would be 8x equals 112, and x is 14. So that's not the question, though. The answer to the question, it's the side length. So we would have to take one of these two expressions. I'm just going to take 20x, plug in 14. 14 times 2 is 28, so this would be 280 meters. Find the perimeter of the pentagon. Well, if you take the one side length, 280 meters, and multiply by 5 side lengths of Pentagon, then you get 1,400 meters. And then find the value of the interior angles. So the same thing, if the angles are congruent, you can set these two expressions equal to each other. So 23y minus 7 equals 17y plus 23. So this would be 6y is 30, y is 5. Plug it in back into one of the expressions. So 23 times 5 minus 7. Oh, goodness. Can we do mental math? 25 times 5 is 125 minus 10 is 115. Minus 7 is 108. So, but that's the one angle. So if we wanted to find the sum of all of the angles, we would take this, multiply it by 5, and you get 540 degrees. All right, so that is the end of this lesson. Now you will move on to the edge elastic assignment, which you'll be doing in class tomorrow.